I want you to think back to the last time you asked a large language model to draft something for you.
Oh, yeah.
Maybe it was an update for your team or a technical blog post. You hit enter, and what comes back is, well, it's technically English, sure.
Barely.
Right. It's this dense, lifeless wall of text that almost always kicks off with something like, in today's fast-paced digital landscape.
Every single time.
And it uses the word delve about 3 times in the first paragraph alone.
Yeah, that's the classic giveaway.
Exactly.
Huh.
And by the time you're done stripping out all that robotic syntax and, rewriting it to sound like an actual human being,
Yeah.
you realize it would have been significantly faster to just write the thing from scratch yourself.
Yep.
We have all been there.
We really have. And it's basically the classic productivity trap of the current AI era.
Yeah.
We have access to these incredibly powerful foundation models, but we interact with them as if they're mind readers. Or worse, we treat them like just advanced search engines.
Right, just throwing a quick request in a chat box.
Exactly. And the methodology we are examining today in this deep dive really flips that dynamic on its head. The core argument in our source material is that the generic robotic output you're getting isn't a limitation of the AI itself.
It's not the model's fault.
No, it's a symptom of under-constrained system instructions. You just haven't defined the operational boundaries for the AI.
Which is exactly what we are going to fix today. Today, we are tearing down a very specific tutorial on how to build a custom AI agent.
And depending on the ecosystem you use, you might hear these called custom GPTs or projects or, in the case of Google's architecture, a gem.
Right. And our mission for you today is extracting the exact blueprint for what this methodology calls the master prompt structure. We are going to look at the specific parameters you need to build a specialized digital clone in under 10 minutes.
And that 10-minute time frame is actually highly realistic, provided you understand the architecture of what you're building.
Yeah.
We're moving away from zero-shot ad hoc prompting, where you just open a fresh chat window and ask for a favor.
Do this thing for me really quick.
Right. We're moving toward managing a persistent, rule-bound system. You establish the semantic constraints once, and then it pays compounding dividends every single time you use it.
So let's get right into that architecture. The process starts with identity. You have to name the agent and give it a strict job description.
Yep.
The tutorial we're looking at uses the example of building a tech edu blogger, and the job description assigned to it is literally just one sentence. Writes, engaging, structured tutorials for electronics and programming.
Simple enough.
So we have our tech edu blogger agent set up. Next, we build the engine, which is the master prompt itself. This replaces those generic system instructions you'd normally use. And the very first layer of this master prompt is defining the role. You are an expert educator and mentor specializing in electronics, Arduino, hardware, open source software, and Linux.
That right there is a highly effective piece of prompt engineering.
How so?
Think about how a large language model actually operates underneath the hood. It's predicting the next most likely token based on a massive generalized training corpus.
Right. It has read basically the entire internet.
Exactly. Everything from quantum physics papers to 18th century poetry.
Mhm.
So by explicitly stating expert educator and tying it to very specific domains like Arduino and Linux, you were essentially pruning the neural network's decision tree.
You're cutting off all the branches that don't matter.
Exactly. You are mathematically weighting the model to pull from a very specific vector space. It doesn't need to search its entire latent space anymore. You've set a highly technical baseline vocabulary.
Right. But knowing the subject matter isn't enough on its own, because I've read plenty of hardware tutorials written by actual experts that were completely unreadable.
Oh, absolutely.
They just assume I already have an electrical engineering degree and I'm totally lost by paragraph 2.
It's the curse of knowledge.
Yes. Which brings us to the next layer of the master prompt, which is the audience. The prompt dictates. Your target audience includes high school students, hobbyists, and absolute beginners. Your tone must be encouraging, clear, and easy to understand.
And that serves as a necessary counterweight to the role constraint we just talked about.
Right.
If you just tell a model to be an expert in Linux and hardware, it's naturally going to drift toward dense academic or highly technical jargon.
Because that's what its training data for those topics looks like.
Precisely. By forcing it to target high school students and absolute beginners, you're instructing the AI on exactly how to translate that expert domain knowledge. You are capping the syntactical complexity.
I do wonder, though, does adding all these layered constraints run the risk of confusing the model?
What do you mean?
Well, if we tell it to be a high-level expert on Linux, but also talk to absolute beginners, does it struggle to bridge that gap? Like, does it get paralyzed?
If the model is sufficiently advanced, like the frontier models we have today, no. It actually thrives on those dual constraints.
Really?
Yeah, it forces the attention mechanism to actively balance the technical accuracy of the hardware instructions against the readability metrics of the output. It essentially acts as an internal quality filter before a single word is even generated.
That makes a ton of sense. Now, let's look at the third layer of the master prompt, which is frankly where this entire strategy clicked for me. It is the format.
A crucial step.
Normally, if I want a blog post, I just ask the AI for a blog post. If I want a tweet, I open a new chat and ask for a tweet. But this methodology insists on defining a strict, multi-part output format that the agent must execute every single time you prompt it.
Exactly. You are hard-coding a standardized operational procedure into the agent.
Let's break down the exact 5-point structure it requires because it's pretty intense.
Go for it.
Point 1, generate 3 catchy titles for the blog and YouTube. Point 2, a structured blog post containing the code or script, a detailed explanation, and a conclusion.
Let's actually pause there for a second.
Okay.
Because combining those first 2 points is highly strategic.
Yeah.
By asking for the titles first, before the blog post, you're actually forcing the model to engage in a form of chain of thought reasoning.
Oh, interesting.
It has to conceptualize the framing and the hook of the article before it even starts writing the actual code and explanation.
Yeah.
It sets the thematic direction.
So it's not just making up a title at the end based on what it rambled about. It's outlining its own thought process.
Exactly.
That's a great point. So then we get to points 3 and 4. Point 3, a social media promotional post for Facebook and LinkedIn. Point 4, a short, engaging post for X.
Now, let me play devil's advocate here for a second.
Sure.
Why bundle all of this together? Why not just generate the blog post, read it over, make sure it's good, and then open a new prompt to ask for the social media copy? Doesn't bundling it all risk a drop in quality if the context window gets too long?
You might think so, but doing it in a single inference pass actually guarantees context alignment.
How so?
If you generate the blog post, close the session, and then later ask for a tweet about it, you risk the model hallucinating or losing the specific nuances of the code explanation you just approved.
Oh, because it doesn't have the fresh memory of exactly what it just wrote.
Yeah.
Right. By generating the social copy in the exact same output sequence as the blog post, the model has the code, the tone, and the educational framing loaded right there in its active memory.
That makes total sense.
And furthermore, from a pure workflow perspective, it saves compute time and it saves your personal time. You are turning one simple topic request into an entire ready-to-publish content strategy.
The efficiency really is undeniable when you look at it that way. But of course, providing the right instructions is really only half the battle here. We also need to understand how we typically sabotage these models.
And we do it a lot.
We really do. The tutorial provides a really stark contrast between common prompting mistakes and actual best practices. Let's look at mistake number 1, using vague instructions. The example given is telling the AI to just write good tech blogs.
The word good is a completely meaningless parameter to a machine learning model.
Because it's subjective.
Entirely subjective. The AI is left to estimate the statistical average of what the entire internet considers a good blog. And that usually results in the most middle-of-the-road generic text possible.
And the countermeasure to that vague instruction is best practice number 1, use negative prompts. Tell the AI exactly what not to do.
A very powerful technique.
The example here is fantastic. Tell the agent, never use the phrase, in today's digital landscape. I actually laughed out loud when I read that in the source, because it is the ultimate tell for AI-generated text.
It really is. Everyone knows it instantly. And technically speaking, negative prompting is an incredibly powerful way to manipulate token probabilities.
Break that down for us.
When you tell a model to be creative, you are asking it to navigate an infinite number of possible token combinations. It's computationally heavy and vague. But when you use a negative constraint, like banning a specific cliché phrase, you are simply applying a negative logic bias to those specific tokens.
You're telling the math, do not pick these words.
Exactly. Mathematically reducing the probability of them being selected to near zero. By fencing off those lazy, predictable pathways, you force the attention mechanism to route through less common, more natural-sounding vocabulary.
I have to push back a little on that, though.
Sure.
If I give the agent a massive list of 50 things not to say, doesn't that just paralyze the model like it's walking on eggshells?
It absolutely can,
Yeah.
which is why you have to be surgical with your negative prompts. You don't want to ban common conjunctions or basic industry terms. You want to ban the stylistic crutches.
Right.
Ban the words delve, moreover, or testament. You are just pruning the dead weight, not tying the model's hands entirely.
Got it.
Okay, moving on to mistake number 2, contradictions. The tutorial warns against telling the AI to be highly professional and academic, but then, further down in the same prompt, telling it to use lots of emojis and slang.
Large language models just don't handle conflicting parameters the way a human would.
Right, a human editor would realize you want a professional tone that is perhaps just slightly conversational.
Exactly. We can read between the lines. An LLM sees two opposing mathematical weights. The attention heads get pulled in completely different directions, and the result is usually a disjointed mess that swings wildly between being stiffly academic in one sentence and overly casual in the next.
To prevent that, best practice number 2 dictates how you physically format your system instructions. You need to use numbers and bullet points exactly like we did with the master prompt format earlier.
Right. Structuring your prompt hierarchically isn't just for your own readability. It directly impacts how the transformer architecture parses the data.
How does that work?
Bullet points act as clear, distinct parameters. It helps the model weigh the importance of each command individually. And it dramatically reduces the chance that you, the user, will accidentally write contradictory instructions because you can see the logic cleanly laid out.
Which leads perfectly into mistake number 3, the wall of text. If you write your instructions as one giant rambling paragraph, the AI is practically guaranteed to ignore at least half of it.
This touches on a really well-documented issue in LLMs called the lost in the middle phenomenon.
I've heard of that.
Yeah. When you feed a model a massive unstructured block of text, its attention mechanism tends to heavily weigh the very beginning and the very end of the prompt. But the semantic constraints buried in the middle just degrade. It will latch onto a few keywords and gloss over the nuanced instructions.
So it basically just skims it like a tired human reader would.
Pretty much.
And the solution to the wall of text, which is best practice number 3, is easily the most powerful capability we're discussing today. Upload knowledge files.
This is massive.
If you have a PDF of your own best-performing articles, the tutorial says you should just upload it directly to the agent's knowledge base instead of trying to describe your style.
This is where we leverage retrieval augmented generation, or RG.
Right.
Instead of writing a massive wall of text trying to explain your specific sense of humor, your pacing, or how you typically format your code blocks, you simply put your past work directly into the context window.
But wait. If I upload my old blog posts, aren't I just risking the AI plagiarizing my previous work instead of coming up with new ideas? If I ask for an article on a totally new sensor, will it just spit back an old article about a different topic?
That's a very common, very valid concern. But it all comes down to how you frame the uploaded document within your master prompt.
Okay, so what do you say?
You don't tell the AI, use this data for your facts. You instruct the AI. Analyze this document strictly as a stylistic reference.
Ah, okay.
When properly prompted, the model uses the embedded document to map your specific syntactic patterns, your sentence length variability, and your exact vocabulary distribution.
So it's copying the vibe, not the data.
Precisely. It acts as a high-weight semantic reference for how to write, not what to write. It essentially maps its token prediction to your personal voice.
You are literally giving it your brain on a silver platter. It's incredible. So let's look at how all this comes together. We have defined our tech edu-blogger identity. We've built the master prompt with roles and audiences. We have our 5-point formatting structure, and we've avoided the vague walls of text.
We have a solid foundation.
The tutorial then moves us to the final step: testing, refining, and iteration. And there's a strict golden rule here. Never deploy an agent into your workflow without testing it first.
It's an essential quality control layer. You've just built a very complex set of semantic constraints. You need to verify how these parameters actually interact during an inference pass before you trust it with your daily tasks.
The tutorial points out exactly what you should do when the output isn't perfect, because it won't always be perfect right out of the gate. Let's say you read that weather station output and you notice the paragraphs are just a little too dense for an absolute beginner. The natural human instinct is to copy the text into a Word document, grab your cursor, and start manually chopping up those paragraphs yourself.
Right.
But the absolute golden rule here is, do not manually fix the generated text.
This requires a fundamental shift in how you view your relationship with the software.
Explain that.
If you manually edit the text, you are committing to manually editing that exact same syntactical error every single time you generate a new article. You are still doing the machine's work.
So you're just a glorified editor at that point.
Exactly. The methodology dictates that you go back to the system instructions, the master prompt, and add a new permanent constraint.
Right. So instead of hitting backspace on the output, you go into the back end and add a structured bullet point that says, keep all paragraphs under 4 sentences, and then you run the prompt again.
You are adopting the managerial mindset.
I love that phrase.
You're debugging the machine itself, ensuring that it never makes that specific stylistic error again. It's a localized investment of maybe 30 seconds that saves you literally hours of manual line editing down the road.
Building a custom AI agent isn't a one-and-done magic trick. It's an ongoing process of refinement. The more edge cases you hit, the more you tweak the system prompt, and the sharper your digital clone gets.
It requires patience up front, absolutely. You have to build the system. But the return on compute and personal time is massive. You transition from a writer staring at a blank, blinking cursor to a system manager reviewing a nearly finished product that already aligns with your technical voice.
So to summarize the blueprint we've extracted today, it really comes down to 3 core principles.
Yeah.
Number 1, define the role and audience. Give your agent a clear identity to prune the neural network's focus.
Essential.
Number 2, be explicitly structured. Avoid vague instructions, dodge the wall of text, use negative constraints to kill cliches, and upload your knowledge files for style mapping.
Use the RG.
Yes. And number 3, always test and refine the system, not the output. Adopt that managerial mindset.
It's a highly logical approach to an inherently probabilistic technology. By applying strict semantic constraints, you strip away all that generic robotic noise and force the model to work within your specific parameters.
You actually build a tool that works for you rather than you working for it. This has been a fascinating look at the mechanics of prompt architecture.
It fundamentally changes the dynamic of content creation.
It really does.
But I want to leave you with a final thought to mull over something that arises when you take this methodology to its logical conclusion.
Okay, let's hear it.
If you follow this blueprint perfectly, if you upload your past work to map your exact syntactic style, if you meticulously define your target audience, if you hard-code your thought process through strict formatting rules, and you successfully create a digital clone that writes exactly like you, when you feed that agent a one-sentence prompt and it generates a highly original, technically accurate article, who's the real author? Are you reading the AI's writing, or have you just architected a way to write at the speed of code?
Wow. That is the defining question of this entire technological shift. Are you the writer or the architect of the writing? We will leave you to ponder that one. Take this master prompt to blueprint, apply the constraints we discussed today, and see exactly what your digital clone is capable of. We'll catch you on the next Deep Dive.